Hi you guys, we're going to be learning about distance formula today. So our definition I need you guys to write down for distance. That means that it's the absolute value of the difference between 2 points A and B, and it's going to be written as AB, or it can also be written as that length of segment AB. So for what number 1 wants to do for us, or we're going to do, it says plot the endpoint A, which is the point -1, 3, and then the other endpoint B, which is 5, 3, and we're going to plot this on the graph. So let's go ahead and plot these points first. So I have a -1, and I'm going to go -1 to the left, and then up 3. And we're going to label that point so we remember what one it was. This is my A. And then now we're going to plot my next endpoint of B. We're going to go over to the right 5 and then up 3. Plot that point and go ahead and actually label it B, because then that's our other endpoint. And then now we actually can connect our line. This is our actual line segment that we see here. So when we have our line segment, we are now trying to determine the midpoint. So we want to just find the coordinates of our midpoint. So if we actually can look on here, and we can visibly see it. So if I go 1, 2, 3, 4, 5, 6, there's actually 6 points. So half of 6 is going to be 3, so 1, 2, 3. So that should be at least the, now if this is my midpoint, so I'm going to label this one M. There should be the same, remember there should be the same distance from each of these. So 1, 2, 3. And then coming from here we have 1, 2, 3. So yay, we do have the same amount of little length on both sides, and we are directly in the middle. So that point right there, I had to go over to the right 2. So my x value is 2, and then I had to go up 3 from the origin. So my point is 2, 3 if I just find the midpoint graphically and visually on the actual graph. Now we need to find the length of the segment here. So we're going to find the length and we're going to use the formula that's talking about up here for our distance. So I'm going to take the absolute value, and the way we find this is by using our x values here. So this will be my x1, this will be my y1. So, or sorry, x2. There we go. Okay, so we have our x2, we're going to take the difference, which means subtraction. And once we have our subtraction of those values, so x2 minus x1, absolute value, I'm going to plug in those values, so absolute value of 5 minus a -1. Remember that a negative times a negative is actually a positive. These bars, little absolute value bars, mean that I'm just going to be taking whatever value I get inside here. It will have to come out positive, because a length can always be positive. We can't have a negative length. This case it actually does work. I get a positive 6. No matter what, it's going to come out positive. So my length of that segment AB is actually 6. Okay, so I am just writing the length of segment AB is 6, just so we know what we're actually talking about there. Okay, so that's our first example. We just found the length of it, because if we did 3 plus 3 like we actually added, we'd actually get our 6. So we have it on our both sides. Let's move on to another example. Now we're going to plot the point 6, 1. We're going to label that E, so that's one of our endpoints. So 1, 2, 3, 4, 5, 6 to the right, up 1. And then we are going to label that E. So remember that that's one of our endpoints. And then let's label our next endpoint of -2, 5 to the left 2 and down 5. And we're going to label that E, or F, sorry. Okay, so now all of a sudden we're going to connect our points, and we definitely do not have a straight line. We don't have a straight line where we had it on this segment last time. So we are now going to determine here. We're going to go through and actually do something a little bit weird. We used Pythagorean theorem in our lesson previously before this, so that's what we're going to actually use to help us determine some of this. Okay, so to find the coordinate of our midpoint, instead of trying to figure out, like we can't just say, oh, yep, that point right there looks pretty good. It might be close, but we have to be kind of more exact because this point's actually diagonal now. So what we're going to do is we are going to use our rise over our run, and we are going to check to see what those values actually are. So I'm going to come from my F, I'm going to go up 1, up 1, 2, 3, 4, 5, 6, and then I'm going to go to the right. 1, 2, 3. Oh, I didn't go up enough. Sorry. Let's go up higher. We got to go all the way to the E point. Okay, so I went 1, 2, 3, 4, 5, 6. And then I'm going to go to the right. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that was my rise, was the 6. My run was the 8. And so now, what we do from there, we are going to go to the middle point. If I have 8 here, I have to go to the 4. So I'm going to count 1, 2, 3, 4, which is right here. Go down to that line, draw a thing that's going down to that line. Let me change the color too so you can see I'm changing this. And then 6, half of 6 is actually 3. So I'm going to go to there. So I counted 1, 2, 3 from that point, and then now I actually have my dotted line, and then this point right here should be the actual midpoint. So my coordinate, and we're going to test this to see if that's true, and so we have our actual coordinate, we went to the right 2, and we went down -2, or down 2. So our coordinate is 2, -2. And again, we use that with our little triangle right there, and in order to determine our midpoint for that. So now our next step is actually going to help us. We're going to use our Pythagorean theorem to find the actual length of EF. This is where the Pythagorean theorem will come in handy and help us on this. So remember that the Pythagorean theorem is a squared plus b squared equals c squared. Remember your legs of your triangle, which is this one and the 6 and the 8. So it doesn't matter, those are the legs that just has to be plugged in for A and for B. It doesn't matter which one actually gets plugged in for which. I could have switched the 6 and the 8 as long as they go in for A, B. We do not know what our C squared is though, so we're going to leave that. And actually, that's our actual EF. So remember, I'm actually going to, instead of saying C, I'm going to say that this is our segment EF. And that's going to be squared. You can write this in parentheses if you'd like as well. So now we're just going to do 6 times 6. We get 36. 8 times 8, 48, equals our EF squared. Okay. So then now, this whole thing is squared, so I'm going to keep this in parentheses. So then we're going to add our 36 plus 48. We actually get 100. Let's back up. The 8 times 8 is definitely not 48. How about we try 64? Sorry guys. So 64. Then 36 plus 64 is 100. That equals to EF squared. Put that in parentheses again. So now we have everything added. We're going to take the square root of both sides. The square root of 100, it's a perfect cube, so it's going to be 10. And then the square root and the squared actually cancel out, and we're left with just our EF. So we have our EF is actually equal to 10. So that is, we just used Pythagorean theorem to help us determine the distance of that segment. Because it is a little bit more difficult because it is a diagonal. Alright, so moving on, we actually just came up with the distance formula too to help us. So if A is going to represent the endpoint, and that's going to be our x1 and our y1, then B is going to represent our second y point, that's why it's x2, y2. Then our distance, we will actually be able to determine the distance of our segment by using this formula here. So D stands for distance, and then we're going to take the square root of our x squared minus our x1 squared, add that to our y squared minus our y1 squared, and then we will have our distance. So we're going to go ahead and do this example. We're going to find the length of with the endpoints, or find the length with the endpoints. I shouldn't have had this here. P 0, 4, and Q is our other endpoint, 6, -2, using our actual distance formula. So let's go ahead and label these x1, y1, x2, y2. And now we're going to use the distance formula and plug it into our actual equation. So if I have under the square root, we have our x2 minus our x1. So 6 minus 0 squared, don't forget that, plus, parentheses again, I'm going to extend my square root. Y2 is a -2 minus 4 squared. And that's all we had to plug in our formula. Now we're going to go ahead and simplify. You use PEMDAS, you're going to be using parentheses first. So in our parentheses, 6 minus 0 is just 6, plus a negative 2 minus 4 more. These have the same sign, so you're going to keep the sign, which is negative, and we're going to add 2 and 4, which is 6. We're going to square that. Our distance still is equal to, so now we're going to use exponents because we got rid of or we simplified our parentheses. 6 times 6 is 36, plus negative 6 times negative 6 is actually another positive 36. So now we get to see that we have the distance equals 36 plus 36, square root of 72. And that will be the distance of our segment PQ. However, let's go ahead and break down our square root. So I know that 2 goes into 72, and that goes in 36 times. I also know that 36 is a perfect square, but if you don't notice it and you see your 6 and 6, oh, look it, we have our pair of 6s. That means I will be having a group of 6 come out front, but this little 2 did not have a buddy. They have to stay inside. If you guys like breaking this 6s down to 3 and 2, 3 and 2, you'll see that you will have a group of 3, have a group of 2, which 3 times 2 gets you 6, leaving you with a 6 out in front anyways. So either way, however you guys like to show it, this is your length for PQ, segment PQ. So I'm going to write my final answer over here. So PQ is equal to, I don't think I could fit in there, so 6 square root 2. And it should have that little segment line. Alright, so we just find that distance, simplify that radical. Now we're going to use our distance formula again for this example. I'm going to complete actually this second one for you only, and then I want you to try this by yourself and then answer if our segments are congruent once you guys have completed the first one. So I'm going to go ahead and do the second one for you. So once I do this one, we're going to label this x1, y1, x2, y2. We're going to use our distance formula. Distance equals the square root of 1 minus 3. Actually, sorry, it's a negative negative, so let's do that. So start my parentheses. We have 1 minus a negative 3 squared plus y2, which is 6 minus 1 squared. Alright, so let's simplify our radical. A negative times a negative is a positive, so this is actually 1 plus 3 under here. Under that radical, plus 6 minus 1 squared. Okay, now I'm going to go ahead and actually do 1 plus 3. We get 4 squared. Make sure you got that radical. 6 minus 1 is 5 squared. So now I'm going to go ahead and actually square those values. We have distance equals 4 times 4 is 16. And then 5 times 5 is 25. Go ahead and add those distances. So we end up getting our 16 plus 25. We get 41. And I know that 41 can't be broken down by 2. I know that if you did 4 plus 1, that gets you 5, which is not a divisor of 3. And it doesn't end in a 0 or a 5, so that's actually the farthest we can break down our square root of 41. So actually our segment GH is the square root of 41. That's the farthest we could break this down. Alright, so you guys go ahead and complete this problem on your own. Make sure you're labeling x1, y1, x2, y2. Plug it into your distance formula. Once you get a simplified radical, I want you guys to see if this value is congruent, meaning equal to this GF or GH segment. Alright, you guys, we'll go over this in class and I'll see you then. Thanks, bye.